welcome back. We've got a cloudy, rainy week this week, so just collecting data on how things look for these systems on cloudy days. Typically, on super cloudy days, you're not going to collect much energy. So, for example, if we've got a kilowatt of solar panels, which when using, for example, a 40 amp MPPT solar charge controller, we might get close to a kilowatt of power. On a cloudy day like today, we're actually only going to get somewhere around 60 to 70 watts of power. So it does have a significant impact. That's why here in Texas, we only expect 60% of the days to be sunny. And so when calculating how long it takes to make your money back on a solar system, we assume that you're only going to be collecting energy on 60% of the days because you're really not collecting a whole lot of energy. Now, we've looked at a whole bunch of different controllers here. You can see these are all different here from different manufacturers, and they're coming in different price ranges. And one of the questions a lot of people have is, what size charge controller should I have? And what size solar system should I start with? And as I mentioned before, I recommend starting with a 1 kilowatt system, and then if you want to scale it to a larger system, then just duplicate that system. So for example, to collect a kilowatt of energy with an MPPT 24 volt system, you need probably a 40 amp controller. And if you wanted to subsequently add more solar panels, what I would recommend is just getting another 40 amp MPPT solar charge controller and connecting that to your battery system, and also potentially adding more batteries to your system if you'd like to extend the operation of your system further into the night. I use the solar systems here primarily just to keep things warm throughout the year, or to keep them cool throughout the year until we have an event. And when we have an event here, for example, we want to get the temperature up above 55, then I'll burn propane and firewood for that event, just to make it more comfortable for people. In the summertime, basically, I also have a separate system that I run downstairs in the cellar. And so that cellar system is really well insulated. It's separately insulated from the rest of the winery here. So it's actually kind of like a room inside of a larger room. And because of that, there's also a lot of, obviously there's a lot of wine there, which is in fact acting as a thermal capacitor. So by basically pumping energy throughout the day, and basically we just pump a lot of cold energy, for example, in the summer, into the liquid, which is those barrels, and also into the slab, because everything is above ground here. It's not fully insulated underground. It's very expensive to actually install a real cellar here and maintain it, mainly because the soil is clay and it has a tendency to shift, and if it's not super reinforced, then basically the shifting of the clay in the summer will break your cellar walls. So it's a little different than it may be in some of these other climates with different soil types. And of course there are things that you can do, more expensive things that you can do to make it work, but it's not like building something in sandy loam, for example.